And the second type of sampling distribution that I would like to discuss is sampling distribution of the sample proportion, which has got three interesting properties. First of all, the mean of the sampling distribution is equal to the true proportion. So if you calculate the mean of all the sample proportion that you can get from sampling distribution, you will get that it will be equal to the true proportion, to the true population proportion. The standard deviation of the sampling distribution is calculated as the square root out of true population proportion multiplied by 1 minus true population proportion divided by the square root, divided by sample size, the number of observations n. And if we have large samples, so samples with a lot of observations, the sampling distribution is said to be approximately normal. So the sampling distribution will be a normal distribution, and a sample is considered to be large if we take the number of observations and multiply it by the sample proportion, and if this value is higher or equal than 15, then we can say that the sampling distribution is a normal distribution. Or alternatively, we can take n, so the number of observations, and multiply it by the difference between 1 and the sample proportion, and if we get the value that is higher or equal than 15, then we say that the sampling distribution is a normal distribution. Similar to the case of the sampling distribution of the mean, the sampling distribution of the proportion has its own z-score formula, which is defined in the following way. So the sample proportion minus the population proportion divided by standard deviation of the sampling distribution. Or alternatively, we can estimate it as sample proportion minus population proportion, and if we don't have sigma, we can estimate it easily by taking the square root out of population proportion multiplied by 1 minus population proportion and divided by n sample size. So let's have a look at the example. So let's assume that 60% of all city voters are in favor of the candidate. And in a random sample of 100 voters, what is the probability that fewer than half are in favor of the candidate? So in this case, it is claimed that the true proportion, so the true part of the city voters is who are in favor of the candidate is 60%. So the population proportion is 0.6. We know that a random sample of 100 voters has been selected, so n is equal to 100. And we would like to know that the probability in a given sample is lower than 0.5. So the sample proportion that we are interested in is 0.5. So first of all, we need to calculate the z-score. So we substitute all the values into the formula, so 0.5 instead of p with the hat, so the sample proportion minus 0.6, which is population proportion, divided by the square root out of 0.6, population proportion, multiplied by 1 minus 0.6, once again population proportion, and divided by 100, which is sample size. And we get the z-score of negative 2.04. So since we are interested in the probability that the proportion is less than 0.5, so fewer than half, we can denote this as p with the hat, so the sample proportion is lower than 0.5, which is the same as calculating the probability of z-score being lower than negative 2.06. And to do that, similar to the previous example, we are interested in the area to the left of negative 2.04. So we take 0.5, half of the distribution, and we subtract the p-value that corresponds to the probability of z-score lying between 0 and negative 2.04, which if you open the z-score table, you will find to be 0.4793. So we get the probability that fewer than half are in favor of the candidate in a sample of 100 voters is 0.0207, or if we transform this into percentages, this will be 2.07%.